Now in question number 12, we have a diagram with a curve with an equation y is equals to 4x to the power 1 upon 2 minus 2x and a straight line. They're intersecting at the points B and C. So by calculation, we have to find the x coordinates of B and C. So we'll have to solve the equation simultaneously. So we have 4x power 1 upon 2 minus 2x, which is the equation of the curve, and the equation of the line, which is y is equals to 3 minus x. We equate them, and when we simplify, we get, so bringing the 2x on that side, we have minus x plus 2x minus 4x to the power 1 upon 2 plus 3 is equals to 0. Our equation is x minus 4x to the power 1 upon 2 plus 3 is equals to 0. Now, to make it easier, we can assume that let's take another value, which is y is equals to x to the power 1 upon 2. So, to get rid of this power 1 upon 2, we can whole square both the sides. So, we get x is equals to y squared. So, we can write it as y squared minus 4y plus 3 is equals to 0. Solving this equation, we'll have y minus 3 and y minus 1 is equals to 0. So y is equals to 3 and y is equals to 1. Now we know that y is equals to square root of x. So 3 is equals to square root of x. Whole squaring both the sides, we'll get x equals to 9. And the other value of y is 1, so we can write y is equals to x to the power 1 upon 2, whole squaring both the sides, we'll get x equals to 1. So these are the x coordinates of B and C, meaning the x coordinate of B would be 1 and the x coordinate of C would be 9. Now, in part B, we have to show that B is a stationary point on the curve. So for stationary point, it means that the dy by dx must be equals to 0, and we have to show that B is a stationary point. So differentiating the equation. So the equation of the curve is 4x power 1 upon 2 minus 2x. So 4x power 1 upon 2 minus 2x. Differentiating this, we'll get half into 4, which will become 2x to the power minus 1 upon 2 minus 2x. Now we have the value of x as 1. So substituting 1 in the equation, we have 2 minus 2, which is 0. So this is shown that B is a stationary point, as at B with x coordinate 1, the dy dx is coming out as 0. In the last part, we have to find the area of the shaded region. Now, to find the area of the shaded region, we can divide it into two parts. We can make a triangle. So first of all, we can find the total area of the triangle, and then we can find the area under the curve, which will be this part, and then we can subtract these two areas, and this will give us the area of the shaded region. So we have this point as 4, we have this point as 9, and this point. So to find this point, we know that the equation of the line is y is equals to 3 minus x. Taking y equals to 0, x will be 3. So the base of the triangle is 6, and substituting 9 into the equation, x equals, so the value of x is 9, so we'll get the height as 6, because 3 minus 9 would be minus 6. However, as we are finding the area, we'll take the length, which will always be in positive. So the area of the triangle would be half multiplied by 6 multiplied by 6, which is 18. Now to find the area under the curve, we know that the limits are 9 and 4, so we'll integrate the equation of the curve and then substitute the limits 9 and 4. So for area under the curve, we'll integrate the equation 4x to the power 1 upon 2 minus 2x, and the limits are 9 and 4. So we integrate by first increasing the power by 1 and then dividing by the new power. So adding half, 1 to half, we get 3 upon 2, and then we divide this by 3 upon 2, and 2x, integrating this would become 2x square upon 2, and we can simplify to just write it as x square. So the simplified form would be 8 upon 3 x to the power 3 upon 2 minus x squared. Now substituting the limits, first we'll substitute 9 into the equation, we'll get 8 upon 3, 9 to the power 3 upon 2 minus 9 whole squared. And then we'll subtract it from the lower limit, which is 4. So we'll get 8 upon 3 into 4 to the power 3 upon 2 minus 4 whole squared. So we can just substitute all these values in a calculator and get our values. However, so this 9 to the power 3 upon 2 would become 27. So this will be 8 upon 3 into 27 minus 9 square 81 minus 4 to the power 3 upon 2 would be 8. So we'll get 64 upon 3 minus 16. Simplifying these values, we'll get 43 over 3. Now subtracting it from the area of the triangle, which was 18, we'll get 18 minus 43 over 3. So this is the area of the shaded region. And this is 18 minus 43 upon 3. So we have 18 times 3, which is 54 minus 43 upon 3. The final answer would become 11 upon 3 or 2 wholes 2 upon 3.